Hello everyone, I am Syed Mushahid Hussain. In this video, we are going to solve two lead code questions. The lead code problems are one of the array and the second one is of linked list. So in first one, we will be dealing with the complexity of time, and in the second one, we'll be dealing with the complexity of space. So the problem here we have is the third maximum number. And the description for this problem is given here. Given an integer array nums, that is a number array, return the third distinct maximum number in this array. If the third maximum doesn't exist, return the maximum number. So it says that if we have a distinct number in an array, so we have to return the third maximum number in that array. If we doesn't have three maximum numbers, or it doesn't have a third maximum number, so we have to return the first maximum number, mean the largest number in the array. So move towards the example. In example one, it says the input of number array is 3, 2, 1, and the output is 1. Here, if we look at this array, so the 3 is the highest one, and the second maximum number is 2, and the third one is 1. So that's why the third maximum number is 1, so it will return 1. The output will be 1. Similarly, we have an example 2. In example 2, we have two numbers in array, that is 1 and 2. So in this case, we don't have a third maximum number. So in this case, we have to return the maximum number. And in the example third, we have three maximum numbers. The first one is 3, the second one is 2, and the third one is 1. So here again, the output will be 1. We have constraints that says that the length of array will be between 1 and 10 power 4. And similarly, the indices, the elements that are in the array, should be between -1 power 31 to -2 for 31 to 2 power 31 minus 1. Okay, it says, can you find an O of n solution? So first of all, let's have a look in this problem. Let's understand this problem. So going towards the problem, that is the lead code problem. The problem is third maximum number. So here we have an array. Let's say it's nums array 1, 3, 2, 7, and 5. If we look at here, so we have the first maximum number, that is 7. The second one is 5, and the third one is 3. So in this case, we have three distinct maximum numbers. So the third maximum number is 3. The final output will be 3. So as we discussed the constraints, so for solving this problem, let's look at the pseudocode and the time complexity of this problem. All right. So we take three numbers, that is max 1, max 2, and max 3, and we initiate it from the integer dot min value, which is the minimum value of the integer class. That is the minimum value in the integers. All right. So in case we don't miss any value that comes in the first index, and that is highest value. So that's why we initiate it from integer dot min value. So for the first maximum value, we have to put a loop. If we use array dot sort, if we try to sort an array, so there will be a complexity problem, and the purpose of our complexity, that is O of n, so that will not be achieved. So the loop is stored from 1 to the length of the less than the null length of the array. So here is a condition: if the numbers of I, mean the element, is greater than max1 that we have initiated with integer dot main value. If the number is greater than max, then the max value, max1 value will be updated to that number. In this case, we will find a maximum number in O of n times, or either it can be find on first index. So here the loop taking n time to finding the maximum number. Similarly, for the second maximum number, we again start the loop from 1 to the length to less than the length of an array, and the condition here is if nums of I greater than maximum 2 and number of I less than maximum 1. I mean, we are trying to find the second maximum there. That should be that number must be less than the maximum 1. So it's again loop of n times, so it takes O of n time. And for the third one, we again start the loop and we find the third maximum number. In this case, in a condition, we are adding that the number that we want to calculate, that this is the third one. So that must be less than maximum 2, the third maximum. So if we have three distinct maximum numbers in an array, so this will be the pseudocode, or this will be the coding pattern for this, for that case. So in case of maximum 3, we will return maximum 3, else we will return maximum 1, the first maximum number. All right. So in this problem, if we look at the problem, we have age condition. Mean what if the numbers dot length is 1? Mean the length of the number is 1. There is only one element in the array. So that will be the best case of our mean of our problem, that is O of 1. And for that we will put a condition if numbers dot length is 1, mean equals to 1, then return number of 0, mean the first index in that array. So we already know that there is only one element and that should be on the index 1. All right. So this is the problem that we understood. Now let's move towards the coding part. We start coding from here. First of all, we put a condition that is for constant time if nums dot length equals to 1. All right, then return numbers of 0. All right, let me zoom it so the code become visible. Okay, now we have to initiate three numbers, that is int 1 equals to integer dot min underscore, that should be in capital, min underscore value. Okay, so we are first creating 3 element. That has been initiated from the very less number. Okay, now we have to find the first maximum number. For that we have to put a for loop int I equals to 0, I less than nums dot length I plus plus. Okay. So here we are trying to find the maximum number, the highest number. So we put condition if numbers of I greater than equals to 1. Okay. Then 1 should be that number. 1 equals to nouns of I. So this will find us the maximum number in the array. After that, we have to find the second maximum number. For that, we put just for each loop number. So here again the condition, or we just can simply copy this and paste it here. Paste it once again for the third one. So here we again trying to find the second number. Okay, greater than equals to 2, and then nums of I also less than 1. Okay, then here 2 will be equals to that number. For checking the third maximum number, we have to put here a boolean, let's say flag equals to, right? So in case of the third one, right, 3, then nums of I less than 2, the second maximum number, that must be less than second maximum number. And if this conditions goes true, so the flag will be equals to true. Okay, and here is the 3 equals to this. All right. So now here the last condition, if I hope this is visible, if flag mean if in case of the third maximum number, then return 3, else return 1. Okay, let's check this. I'm going to run this. Oh, it says that, okay, okay. It's not none, actually it's nums. So there was a compiler error because I put the variable name num, not nums. So now it should be run properly. Okay. 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 So yes, it works. So let's submit it. Yes, this algorithm is more faster than 79% of the online submission, and here you can see the time complexity is 3 milliseconds. Okay, so now move towards the second problem that we have to solve, and that is from linked list. All right, so let's understand the problem. So linked list cycle, the lead code problem is 141, problem number 141, and that is a linked list cycle. So it says give head, the head of linked list determine if the linked list has cycle in it. There is a cycle in a linked list if we have to just detect the cycle in a linked list. All right, so there's a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, POS mean position is used to denote the index of the node that is tails next. Pointer is connected to node that is POS is not passed as a parameter. Okay. Okay. Return true if there is a cycle in a linked list, otherwise return false. It says that if we have cycle in our linked list, then we have to return true. Otherwise, we have to return false. For example, we have four nodes here. The three that is pointing to 2, therefore 2 is pointing to 0, and 0 is pointing to -4, and -4 is again pointing to 2. All right. So in this case, 3, 2, 0, -4, that is our head. That is the head is 3, and that the other nodes are connected to it. So in this case, we can see here a cycle. So there will be the output true. And in second example, we also have an cycle 1 is pointing 2 and 2 is again pointing to 1. So in this case, the output will be true. And in third example, we can see here there is only one node that is not pointing to itself or any nodes. There is only one node. So in this case, the output will be false because there is no any cycle. Okay. Constraints are talking about that the number of nodes in the list is in range of 0 to 10 for 4. Okay. And the second one is -10^5 less than node.val, mean the value in the node can be between these number -10^5 to 10^5. And the position POS is -1 or valid index in the linked list. So the index should be denoted by the POS. Actually, POS is not a parameter for this problem. So it demands us, can you solve it using O of 1, constant memory? So the last question was about the time complexity, and this is about the memory, constant memory. So let's understand this problem. So here the problem is of linked list. Here we can see the list that is 4, 3, 2, 7, and the 4 is the head node and pointing toward the 3, and this pointing toward the 2 and 7, and there is a cycle. So in this case, if cycle in an array, so we will return true, our program should return true, else it return false. So in this scenario, if we have a cycle in our problem, so that will be the pseudocode will be like this, and we also compute the space complexity here. So we have a list, and that has a head node. That is the head node and pointing to other nodes in that array. So we will take two temporary nodes, that is fast and slow, which will be pointing toward the head. Mean the value of head will be assigned to those nodes, and then we will put a loop, and the loop will have a condition of fast if fast not equals to null, and then fast dot next not equals to null. If this condition, then the fast equals to inside the loop, we will update the value of fast and the slow. Okay, the fast one should be assigned to the new value, that is fast.next, and the slow will be equals to slow.next. If fast equals to slow, then return true. It means there is a cycle in that linked list. Otherwise, return false. If this value doesn't mean the condition for the fast becomes false, so it will come out of the while loop and will return the false. Okay, so there is again edge condition in this problem. In case of one, there is only one node that we already saw in the example. So in each condition, what if only one node? Then we will put a condition, that is if head equals to null, or head dot next equals to null, then we will return false. All right. So now let's go to the coding. Okay, this is our problem. So first of all, we have to put a condition of head. If head equals to null, or dot uh, next equals to null. I mean, if we don't have any nodes in an array, so then there will be no cycle. So we will simply return false. All right. Other than this, we have to assign the two temporary nodes, that are uh, list node fast, that will be equals to the head node, that is our head node. All right, so we are creating another one, that is slow, and the slow will also uh, pointing to the head. Right, now we will start here a while loop, while fast not equals to null, and then fast dot next not equals to null. I mean, this loop will be going till the condition goes false for the. Okay, so here inside this condition, we will updating the value of the fast, as well as fast equals to fast dot next dot next, and similarly slow will be updated to slow equals to slow dot next. Right, now we have to put the condition that if they for detecting the cycle. So if fast equals to slow, mean these are just moving towards each other, so that means there is a cycle in a loop, so we simply return true. All right, if this condition goes the while condition goes false, then we will simply return here false. Okay, so let's try to run this code. Okay, it's worked perfectly. So let's submit it. Okay, got it. So this program is 50.87% of Java Online submissions. That is faster than of that. So the memory usage is 45.8. Still, we can provide a better solution that is memory efficient. But this was a quite good solution and efficient solution. So guys, hope you understand these problems and how to solve these problems. That is the lead code problem. One is about the time complexity and the second one was about the space complexity. So hope you guys enjoyed it and understand the problem, and uh, it will, I hope it will put some value in understanding of your coding experience. So thank you and thank you so much.